As you can see here, we have hello world being displayed on our LCD. Now this over here is our code, and in the code we just initialize the pins that we have selected on the hardware. Then what we did is that we initialize the LCD, then we wrote our command LCD out hello and world, hello on the first row, world on the second row. Then we made it to display for 1 second. After that we clear the screen, and then it keeps on repeating forever. So this programming gives us this result over here. Guys, welcome to Learning Microcontrollers. In this video, I will show you how you can interface a PIC16F877A microcontroller with a 20x4 LCD JHD204A, and then we will write a firmware and we will display hello world using MikroC for PIC. So let's get started. So guys, I'm talking about this LCD. It has 20x4 means it have 4 rows and 20 columns. 20 column means that each line can have 20 characters, and there are total 4 lines. So 20x4 means you can write 80 characters at a time on this LCD. Now guys, you can see 2 connectors. One is at the top, one is at the bottom. These both ports are exactly the same. This means that this is pin number 1, this is pin number 1. These are just duplicate of each other. You may use either these 16 pins or either these 16 pins. So let's do the connection. So this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. This is the 20x4 JHD204A LCD that I have, and you can see that I'm only going to use a top connector because top and the bottom both are exactly the same. Then guys, this over here is our potentiometer, 3-pin potentiometer. This will be used to adjust the contrast of the LCD. For this LCD you may not need it, but it is better to have it because 16x2, 16x1 and all the LCDs have exactly the same pin out. So only the thing mostly differs is that these 2 pins for 15 and 16, some LCDs have backlight, some don't have backlight, so rest will be the same. So it is better to have it. Now guys, let's do the connection. First of all, let me introduce you to the pins. So the potentiometer have 3 pins, 1, 2 and 3 mentioned on the body as well. Now for the LCD, if you hold it like this, you have 16 pins, 1 to 16 from left to right like this. Now you connect the pin number 1 and 5 together like this, then you connect it to the pin number 1 of your potentiometer, then you send it to the common ground of your PIC microcontroller. In this way your LCD gets grounded with the potentiometer. Now guys, for the pin number 2 of the LCD, that is VDD pin, this is to power up the LCD. Now you connect it to the pin number 3 of your potentiometer and you send it to the VCC pin of the PIC. In this way your LCD is powered up, your potentiometer is powered up, while the PIC is connected to a 5-volt power supply, which is enough to power up both the components. Now guys, the next thing is the pin number 3. It is a contrast adjustment pin. You connect it to the adjustable pin of your potentiometer, that is pin number 2. Now pin number 4, it is the RS pin. You may connect it to any available digital input output pin of your PIC. I'm going to use a pin number D1. For the pin number 6, that is the enable pin, I'm going to use a D0. Now for the pin number 14, that is data pin 7, I'm going to use a D7 of the PIC. For pin number 13, that is data pin 6, we are going to use the pin number D6 of the PIC. For data pin 5 of the LCD, that is pin number 12, I'm going to use the pin number D5 of the PIC like this. And for the data pin D7, D6, D5, D4, data pin 4 of the LCD, I'm going to use a pin number D4 of the PIC. Now see how beautifully I made them. D7 for D7, D6, D5, D4. You may use any available digital input output pin. I use them because they were available. Now guys, pin number 15 and 16 are for the LCD backlight. This LCD do have a backlight. So pin number 15 will go to the 5-volt positive, 16 will go to the ground. This will light up the LCD's backlight. Even if you do not connect these 2 pins, still the LCD will work, but there will be no backlight. And these 4 pins, 7, 8, 9, 10, they are from data pin 0 to 3, D0, D1, D2 and D3. We will leave them floating, we will not use them because this LCD can be used in 2 modes, the 4-bit and the 8-bit. But for our application, 4-bit mode is more than enough, so I'm going to leave them floating. So this is our total connection. Now let me introduce you to the hardware before we move on to the programming. So guys, this over here is our hardware. As you can see, this is the 20x4 JHD LCD I have, and this over here is the PIC16F877A microcontroller. There I have the PIC3. So PIC3 will be powering up both the PIC and the LCD. So there we have the contrast adjustment resistor, as you can see there. The rest is just a trainer board. So I will also offer this board. If you want to buy it, I can make and send it to you. So let's I also have a lecture on this, how I designed this board. It is also available in the lectures list, so you may go and check. Now guys, let's go to the MikroC for PIC to start writing the firmware. So this is our MikroC for PIC. I zoom in. The version I have is 7. I think it's 60. You may go for the latest version. They have the same command syntax. I also have a lecture on this, how to download and install this for free from official website. Just go and check it out. Click on File, New Project. This window pops up, New Project Wizard. Click on Next, write the name of the project. I write 20204A JHD with PIC16F877A tutorial by learning microcontrollers. Okay, that is the name I wrote. The device name is PIC16F877A, and the crystal I have with the pin number 13 and 14 is 16 megahertz. Now this, okay, there is a problem. We gave wrong. I think something is wrong. Okay, first letter cannot be numeric, so you use the other one. Okay, click on Next and Finish. So this is it. Now before you do anything else, first of all, save your work. Click on Save and Save. That is all. Now guys, first of all, we need to get the library for the LCD. Go to the right in the micro libraries, expanded. You have this library called LCD. Check mark this. Expanded, there you have this command called LCD I90. Double click on this. This window pops up. There in the example here you have these commands. You copy all of them. Go back, paste it above the void main like this. Now here remove these 3 dots, they will cause error, and move the LCD I90 command in the void main. Rest will remain here. Now remember, in the presentation for the RS pin we have set pin number D1. For the EN we are using pin number D0. For data pin 7 we are using D7. For data pin 6 it is D6. For data pin 5 I have selected D5. For data pin 4 I have selected D4. If you select any other pins, then you just have to change these commands. That's all. You may use any available digital input output pin. So now see, this is the 4-bit mode. If it was the 8-bit mode, I was to also initialize D0, D1, D2 and D3. For the 4-bit you only need these 4 pins. That's all. Now also do the same. This was for the pin layout setting. Now this is for the pin direction. Now for the again for the RS, exactly the same. Just repeat here. D1, D0, then it's D7, D6, D5 and D4. That's all. Now guys, this is the pin initialization. Now this command initializes the LCD. Now your LCD is initialized. Give some initialization delay, not necessary, but I always suggest you give it in the one-time loop. I write delay ms 200 milliseconds. That will be enough. Now guys, here we got our LCD initialized. Now the next thing is we go to our forever loop and do the programming. I write while 1, forever loop starts here and ends here like this. Now guys, here what I have to do is that I go to the right in the LCD library. There you have this command called LCD out. Double click on it. Go to the example here. You have this command, LCD out command. Now this command LCD out, this is your row number 1, and this is the column. Start writing from the row 1, column 1. What it should write? Hello. Okay, we want to display hello world. I make it capital, hello. And on the second row, just write something like world, like this. And I make it row 2. This is it. Now on the first row, first column, from the first column, it will start writing hello. On the second row, from the first column, it will write world. So this is a simple code to write hello world. I build this code, built, no error. Okay, that's perfect. Now we go to our PIC16 programming tool. Click on File, Import hex file. This is the file we created. I click on Write. Okay, the file is being written. Let's wait. So the program is written. I go to the, okay, here you go. The LCD is here. Okay, now let's power it up using the PIC16 programmer tool. I click on. The circuit is on. Now see, it is showing hello world. Now this is because of my camera. The camera is not able to like capture the exact color because of the backlight of the LCD, but I try to make it look better. I adjust something. Okay, here you go. We are receiving the data that we just sent. Now you can play with the code. You can send anything that you want. Okay, what I do is that I go back to the code. I now make it like toggle. Now to toggle it, either you send an empty like this. You may write like this, LCD out, and then just send a empty line, you will be able to remove it, or you may use a command. Go to the right, there you have this command LCD CMD, and here you have this command called LCD clear. Now we display this like for, okay, go, I forgot to copy it, I think. Copy this LCD CMD command, this clear the LCD display, you paste it here. Now give the delays, so copy this delay, and we want to display this hello world for like 1 second, and after that it clears the screen, and screen remains clear for like 100 milliseconds. So in this way it will look like it is toggling. So I build this code, I go to the PIC16 programmer tool again, I click on write. Okay, the new code is being written. Let's go back to the LCD. So see, the code is being written, so it is showing distorted values. Wait for it to write the code. Wait, the new firmware is being uploaded. Now see, it looks like it is toggling. See, hello world. Now this color is all because of the camera, because the camera I have is unable to capture it. See, it looks as it should work. So guys, this is it. I hope you guys learned something from this video. We'll see you in the next lecture. Goodbye until then.